Yeah. Okay, read the question. No, this is I'm projecting it. So first, what it do? It will collide. This is the wall. This is the wall. Left wall. Wall one. Wall two. Now, first of all, you go back to the projectile motion. What the maximum height attained by the ball? Y component of velocity will determine maximum height. H max equal to u square sine square alpha by 2g. And this is what that H max is here. Now first what happened, the ball is projected from point 2 with a speed u. Now what, how the trajectory of the ball will be. It will collide first at point 1. Collision 1 will occur. Then it will still have y component of velocity. Then because of y component, it will further ascend. Then 2, 3, 1, 2, 3, 4, 5. Then it will retrace path. So collision 2, 3, 4. Here it will collide 5, then 6, then 7, 8, 9, and it will fall back to the same point. Don't count this as collision. Again at point 2, it will retrace path. So what all this? This is for my convenient. I just drew it. So I'll put dotted line. Yeah, this is what happening to the ball, that one. So now, sir, how you are managing that hole? So let's see that what is the given distance d by 2. How much of horizontal distance it will move to reach 0.5? D by 2, d by 2, d by 2, d by 2, d by 2. Now he has given one more, that in the absence of the wall, its range would have been 5d. Its range would have been 5d means one more wall is needed. I'll draw the vertical lines properly. So this is one. Rough diagram. Huh? This is. Yeah. So the range would have been 5d, no? So the distance between the walls, what happened is d by 2, as it is the elastic collision. So d by 2, d by 2, then d by 2. So this will be remaining how much? 5d by 2. Able to analyze the question? So the wall, what will happen? Will just only reverse the x component of velocity with every impact, and the y component, what happen, will remain unchanged here. Because of as long as y component is non-zero, it will keep on ascend. Then at maximum height, what should be the y component velocity? Should be 0. It will have horizontal component how much? Ux only. So then with that, it will retrace a path. So how many collisions are there? 9 collisions total. Point at which the ball finally falls will be at initial point. I think that's what he has given all the options. So how long the ball will ascend between the walls? As long as y component of velocity is non-zero. If the inelastic collision, what conditions will arise? If the inelastic collision, it may not retrace path. It may not come back to point 2. But as long as y component is non, and it may Now, finally, what should happen to it? Because of inelastic collision, it may not strike at highest point. Before reaching highest point, only somewhere here only what when x component of velocity becomes zero, no? Then y component non-zero. Then it may fall. So many consequences are there. Elastic collision, okay, we can make it very simple. Okay, let's take the next idea. No, to read the questions. Very good.